Okay, so through this point we have completed 45, 47, 49, and 51, and I will go on to complete the remainder of this set. Okay, so in this set we'll try to get through 53, 55, and 57. Now with 53, you want to notice that you have the natural log of t divided by t squared. So we really have two different functions there, and we're going to need to use the quotient rule on this. Okay, here we go. So we have low, which is t squared. Then the derivative of the numerator, derivative of ln of t with respect to t, is just 1 over t. So that's low d high minus high, which is ln of t. D low, the derivative of the denominator is 2t, and all divided by uh, low squared. So t squared raised to the second power, which is t to the fourth. Alright, so at least you should see that t squared times 1 over t is going to, one of the t's will cancel there, and we'll just get t out of that. Then minus 2t times the natural log of t, and that's all over t to the fourth power. Alright, so again we do have a t in the numerator that we can factor out, and that t will cancel with one of the t's in the denominator, and we'll get 1 minus 2 ln t over t to the third power. Alright, so that's probably the best form to leave it in. And we're going to see in the next section that what we really want to do with this stuff is we want to find where it's 0, because whenever that derivative is 0, then we know that we have a stationary point. We have a horizontal tangent line, which will tell us that we've either have a minimum or a maximum in the function there. And so now it's easy to find where that function is 0. A rational function is 0 when its numerator is 0. So we take the numerator, 1 minus 2 ln t, set it equal to 0, and then we start to solve that, and we'll see how we go about doing that. Let me just go through that right now so you can see. If I was looking for where this is 0, alright, well, let's hold off on that for the time being. Let's go ahead with the rest of the problems that we have here. And let's not go off on a tangent, as they say. Alright, so we have number 55, the natural log of the natural log of x squared. And we can do a couple of things with that. We can bring down that 2 that's in the exponent and rewrite this as we're looking for the derivative of the natural log of 2 times the natural log of x. And so recall that you have an outside function and an inside function. Don't be intimidated by the fact that they're both natural logs. We just keep going the way that we normally proceed. So the derivative of the natural log of something is 1 over that. And so we start with 1 over 2 ln x. Now we need to multiply that by the derivative of 2 ln x. And the derivative of 2 ln x is just 2 times the derivative of ln x, which is 1 over x. So we get times 2 over x. At that point, the 2 constant in the numerator and denominator cancel, and we end up with 1 over x times the natural log of x. And that should be the way that 55 ends. Alright, with 57 we have y is equal to the natural log of the square root of x plus 1 over x minus 1. And we can rewrite that as the natural log of x plus 1 over x minus 1 to the 1/2 power. And since it's the natural log of something raised to a power, we can bring that 1/2 down and rewrite that as the derivative of 1/2 times the natural log of x plus 1 over x minus 1. And you recall that we do have a property of logs. The log of a quotient is equal to the difference of the logs. And since that 1/2 is really going to be multiplied times both of those terms, I'm just going to bring the 1/2 all the way out. So I have a half times the derivative of the natural log of x plus 1 minus the natural log of x minus 1. And you're going to see how easy this is. We have 1/2 times the derivative of the natural log of x plus 1 is 1 over x plus 1 times the derivative of x plus 1, which is just 1, so that's all there is. And then the derivative of natural log of x minus 1 is 1 over x minus 1 times the derivative of x minus 1, which is also 1. So we end up with 1/2 times 1 over x plus 1 minus 1 over x minus 1. And I really should get a common denominator of x plus 1 times x minus 1. And I end up with 1/2 times x minus 1 over x plus 1 times x minus 1 minus x plus 1 over x plus 1 minus x times x minus 1. And be careful, you have to apply that negative sign to the whole x plus 1. And we'll continue in the next video.